Hey everybody, and welcome back to Higher Learning Test Prep's online video tutorial series. Today we're going to look at a fairly difficult geometry question, number 45 here on an ACT test. So we had a student that was wondering how to do this question, sort of a head scratcher here. We know that points A through F lie on a circle shown below so that the distance between any two adjacent points is equal. The circle has a diameter of 9/2 inches. What is the length in inches of AB? Couple of different ways to do this question. First of all, we know the diameter is 9/2. So you might draw that in from maybe E to B here. And you'd say that's 9/2. Okay, we know that. Now I'm always looking for the hidden triangle in questions like this. Whenever I have a tough geometry question that doesn't give me a triangle, it's a good chance there's a hidden triangle in there somewhere. If these two radii meet in the middle of the circle, which they always do, despite the fact that my drawing skills may make it look like it isn't the middle of the circle, it is. This is the center. That means these radii are each half of 9/2, which you could say is 9/4. Now, once you know that the radius is 9/4, there's a couple things to remember here. Well, AB, the arc length, is equal to all these other arc lengths, and there's a total of 6 of them. So at that point, you could say to yourself, well, if there's 6 equal parts of this circle, we could divide our entire 360 degrees by 6, and we would know that each of these central angles is worth 60 degrees. Now, if this angle right here is 60 degrees, and we have already 2 sides that are equal, that means that we have 3 equal sides. Because if we have an isosceles triangle, just to break this down, I'll draw it up here. We have our isosceles triangle, 9/4, 9/4. That means that these opposing angles are also equal. The angles that are opposite of our sides are equal. So now we know that these two angles are equal. And if this one is 60, that means we have, of the entire 180 degrees in the triangle, we could subtract that 60, know that the other two are 120, and of course, because they're equal, each of those is therefore 60 and 60. When you have 360-degree angles, you have an equilateral triangle, meaning that our side length of AB is 9/4. Awesome. I hope that helped you solve this question. The big thing to remember here, aside from a couple of geometric principles about isosceles triangles, number of degrees, we have this 360 divided by 6 piece, which was certainly important. But the most important part was looking for the triangle within this circle. We know that oftentimes on ACT math questions, it all comes down to finding the hidden piece, a triangle within a circle, a square within a circle within a triangle, something like that. Look to draw a little bit on your figure and find out what's going on here. Okay, I hope that helped out with this geometry problem. If you have any other questions, please let us know. We'll make a video for any question you have on the ACT or SAT. HigherLearningTestPrep.com. We're also available for questions on Facebook and Twitter. Get at us and we'll be happy to help you in your quest for the perfect ACT score. Take care.